All right, so in our last video, we learned how to identify the midline, the amplitude, and the period from the graph of a sinusoidal function. Now we're going to learn the rest of the properties and how to write equations of these. So to do this, let's consider how the midline, amplitude, and period affect the graph. And then look at it through a lens of transformations like we did in Algebra 2 and again this year in Pre-Cal. So it says the midline of a sinusoidal function is simply a vertical translation. So that midline on our basic sine and cosine was at 0, and then we saw some graphs where it was moved up or down, and that midline ended up somewhere else. That comes from a vertical translation. So the midline is going to give us that vertical translation. Now, for the amplitude of a sinusoidal function, that is a vertical dilation. So with a translation, remember, you're only just picking up the graph and moving it up or down. It does not change its size. Where the amplitude is changing the size. The basic sine and cosine is 1 unit long, but we saw some that had an amplitude of 2 or 3, and so it was going vertically a lot more. So that's our vertical dilation. Now, the period of a sinusoidal function is the result of a horizontal dilation. So in this case, we're getting more than one period or less than one period done in that 2 pi that comes from our standard sine and cosine function. You talked a lot about those in Algebra 2, and they didn't make quite as much sense in the Algebra 2 function. So actually, this is a little bit easier than it was in Algebra 2 to do the horizontal dilations. All right, so we're given a function here written as f of theta equals a times sine of b theta plus d, or the same for the cosine. The graphs of f and k will have the following transformations. So these look exactly like the ones you learned in Algebra 2, the ones we used earlier in the year. The a value is that vertical translation, b is that horizontal dilation, d is the vertical translation. So vertical dilation, horizontal dilation, vertical translation. We'll even get to our horizontal translations later on. So it says a vertical dilation by a factor of A. A represents the amplitude of the graph. A vertical translation of D units, D represents the midline of the graph. And a horizontal dilation by a factor of 1 over B. The period is given by 2 pi, which is the standard for our cosine and sine graph, divided by that b. So here's an example of that graph right here. Our midline is 3 in this case. Y equals 3. Our amplitude would be 6 because from 3 to the top of our graph at 9, there are 6 units. And from the midline of 3 to the bottom of our graph, which is at -3, is 6 units. Now the period is one full cycle of this, and so we see it started right here, ended right here, and so that is 1 pi. So there's all of the information on it. So let's talk about those values. So we said A is the amplitude, and that's going to be our vertical dilation. In this case, we just talked about it being 6, so our A value would be 6. Our B value, we said 2 pi divided by that B value. So we're going to get the B value, and in this case, it came out to 1 pi. So 2 pi divided by 2 gives me that 1 pi. So our B value would be 2. And then our D value is that midline. We've moved from the x-axis up 3, so the D value would be 3. If we wanted to write the equation for H, we would say 6 sine 2 theta plus 3. Okay, we'll keep trying those. Let's look at some more examples. On our graph of f here, for our second example, they've given us a graph and they're asking us to write the equation of this. So let's look at what's happening. The first thing I'm going to look at is where is my midline? That's right here. That helps me find the amplitude, and that gives me the D value. So our D value here is 3 because that is where my midline is. Now from that midline up or that midline down to the bottom, to the local max or min, we'll find the amplitude. Well, that's 3 units that we're going up and down from that midline. That's my A value. So A is 3, and the D just happens to be 3. That was a coincidence. Now we need to look at our period. So from here to here is the period. And so that is 1 pi. We see that there. The B value comes from 2 pi divided by B is going to give me the period. So in this case, the period is pi, so I'm going to set that equal to pi. That helps us come up with what this B value is. Now, pretty quickly, you can see the B value in this case is 2. If you could not do that, then you would cross multiply to solve. Now that we have these values, we can write our equation. So f of theta is equal to 3 sine of 2 theta plus 3. So it went up 3. So from the x-axis to this point, we had a horizontal dilation by 1/2. And so it took the normal period of 2 pi and it has taken it down to half of that, which is 1 pi. Remember, that's what this value was. This B value was a horizontal dilation by 1 over B. So this would be by 1/2. We took that 2 pi where we created one cycle in the regular sine and cosine and we shrunk it by half. So that's my horizontal dilation. Then my vertical dilation by 3, I took it from the top and the bottom and we stretched it this way. So the regular sine and cosine have an amplitude of 1. And then with a vertical dilation of 3, it goes up 3 and down 3. We're going to keep going with some of the question types that you're going to see in AP Pre-Cal on the exam. So it says the figure shows the graph again. What are the values of the period and the amplitude of G? So you can check that G, that period at any point. So I can say from here to here. We can say from up here to up here. You are looking for that distance that it takes for that pattern to repeat. So wherever you think that's going to be the easiest, in this case, I think it's going to be the easiest from right here to right here. That is a distance of 1 pi. So I know the period is 1 pi. I can easily take out both of those because the period is the easiest thing to look at. Now from the midline here to the top or the bottom, I can see it's gone 2 units. And so our amplitude would be 2. And so that gives me the answer as A. All right, so on our next example here, it tells us the trigonometric function k has a maximum at the point 0, 6. After this maximum, the next minimum occurs at the point, that should be a pi. That did not print very nicely. That's a pi there. Pi over 2 and -4. Which of the following could be the expression for k of x? All right, so we looked at some of these on the last lesson where we talked about the maximum and minimum. Remember, if this is the max and this is the min, then this is half of the period because you would need the other half to get back to the maximum. So keep that in mind as you go. So I'm going to go ahead and look for the period of this one first because that's going to help me understand this graph. So it went from 0 to pi over 2, which is a half a pi. If we double that, then it would be 1 pi. So our period is 1 pi. Now to get that in the equation, remember it is 2 pi over b gives you the period. So again, in this case, our b value is 2 again. So now we know it has to be one of these two. So I can cross out my A and my C. Now, the next thing I'm going to want to get from this information they gave us is the amplitude. And so this is going from -4 to 6. So there are 10 units in between these on the Y. So halfway would be our amplitude and our midline. So if that is 10, we need 5 for our amplitude. And so our midline would occur 5 up from this or 5 down from this, which is at y equals 1. So we can see that the d value is 1 there from the midline. Our amplitude is 5, so our answer is D. The more information you pull from it and understand, the easier it is for you to get the correct answer. All right, the next one says the trigonometric function f is given by the equation f of x equals 3 times sine of 2x minus 1. Which of the following could be the graph of f of x? So the first thing I would want to look at is this midline. This makes it super easy to look at. We know our midline is going to come from that value there. Basically, it's been vertically translated by -1. So if I look at my midline on this one, it is right here. That's at +1, so I know it can't be that one. If I look at my midline between these right here, that's going to be there, which is -1, so that one can stay. This one will also be -1, and this one will also be -1. So we've got this one is being crossed out because it was at +1. The next thing we want to look at is that amplitude. We want an amplitude of 3. And so from the bottom here of -4 to the top, which is 2, that is 6. And so that would be an amplitude of 3. Here we have, again, 6. And then on this one, we have 6. So we can't eliminate anything else by that one. So the next thing is to find the period of this. So our period is 2 pi divided by the b value, which in this case is 2. And so we are looking for one that has a period of 1 pi. So from here to here, that's 1 pi. So that one works. Now if I look at this one, from here to here would be the period. Well, that's a distance of pi over 2, from 0 to pi over 2. So that is not okay. This one here goes from here to here for a full period. That's when the pattern repeats. And so that distance is 2 pi, from 0 to 2 pi. And so that period is too big as well. So that is eliminated. C is the correct answer on that one. In these graphs, sometimes the horizontal translation is one of the harder ones to do. So we've left that here. That's called a phase shift. So a horizontal translation for the sine graph is called a phase shift. The graph of g of x equals sine of x plus c is a phase shift of the graph by -c units. We've talked about this earlier in the year. Remember, this is supposed to be x minus. You can look at it that way, so it turned into a -c because this goes to the left. So that c value does have to be negative there. The same results can be applied to the cosine ones. So now we're talking about inside of the sine here. That's where our c is found. That's what does our horizontal translations or our phase shift in this case. So the figure shows the graph of a trigonometric function. Which of the following could be the expression of g of x? And so one of the things that's confusing, notice that these are cosine and these are sine. So you really do have to think through that part. It's important. All right, they all have a -1 as the midline. So we know that this right here is our midline. Right there. They all have an amplitude of 3. So neither one of those facts are going to eliminate any of the answer choices from us. So the first thing we want to do is think about our sine graph. And so I'm going to sketch 2 little pictures here just so that you can see that. The sine graph looks like this. Our cosine graph starts at the top and goes up this way. So keep that in mind as you're looking at these graphs. So here's my midline at 0. We do not have a value there. So I would start with the cosine. I can say instead of at the top, it's at the bottom. So this could be a negative cosine. So we could look at these graphs if we want to look at that. There are shifts on all of these, so we got to think about that. So that helps us eliminate this one right here because we know that at the cosine, it's supposed to be up here at the top. This one is at the bottom. So if it had a reflection, we could say that was the cosine, but this one has not moved left or right. And so it would have to be up here for it to be that cosine graph. So I can go ahead and eliminate that one. All right, for our next cosine graph, this one here has that reflection. So that would work starting here, but it moves to the right pi. And so if here, I would have to move to the right 1 pi unit. And so that means our point should be right here. So that also eliminates this one. Now we'll talk about this one. So our sine curve starts at the midline. So this function is supposed to start right here, but it does not, but we do have a horizontal shift, so that's okay. It says it is going to the left pi over 2, and so we would go to the left pi over 2, and that's over here. So I might try my next one. Sorry, where is? Right here. And so if I go to the left pi over 2, I'm right here at 2 pi, which is where this graph would go. So that is a possibility. Now let's look at this one to see this one. So we start at sine, which is right here. It says to go to the right 3 pi over 2, which is right here. That there is a point right there, so that's a good start. My graph is supposed to be right here and go this way. Now it has moved to the right 3 pi over 2, so I'm right here. And then it is shifting, it is going down. The negative reflects it. So instead of going up and this way, it is going down and this way. So this needs to be my correct one. This matches right here. For the rest of the values here, I would definitely want to check to make sure that everything worked out with it. And it does not work completely, because if we followed this graph here, my next value would be at negative pi over 2 here. And this went to the left pi over 2. So left pi over 2 would be right here. But remember, the sine curve goes up and then down, and there's no reflection here. So this one can't be. So you do have to think about all of the different things that you're pulling from that equation. Here's another one to try that out. All right, in this case, they all have a 2 here. So now we know the period is pi for every single one of them. That's not going to eliminate any of them. Same thing with the amplitude, same thing with the d value. So the only thing that we need to eliminate is our horizontal translations. So first thing I'm going to do is draw my midline there. Right there. All right. So I would start here with my sine curve, would be here. This first one says to the right pi over 4. So to the right pi over 4, I'm right here. It is going up and then back down and following 2 right here. And so that actually works. So I'm going to hold that thought though and make sure that the rest of them do not. And so this next one, I would start right here. Here's my sine curve. I'm moving to the right pi on this one. Well, that's right there. That does not work. So I can eliminate that one. For a cosine, I'm supposed to start at the top. So I would be right here. Move it to the right pi. Well, that's right here. There's no point on my graph there, so I can eliminate that one. This one here, cosine, starts at the top. It says to move to the right pi over 4. Well, that would be right here. Since this is half of a pi, then it's right here. And there's no point on the graph there, so I could eliminate that one as well. So that's what you're doing when you're working through here, is start at that point where we learned that sine and cosine graph. Start with that one, know that one really well, and then apply the transformations to see if your points are on the graph or not. All right, last thing we're going to look at for today's video here is the FRQ part again. So we've talked about how this FRQ part is the same on the AP exam each year. You just need to be able to write the points, write the equation, and then answer some questions about the graph. So in this particular part of it, it is giving me what F, G, J, K, and P are. So I'm going to go ahead and write them there just so that I have those values right on the graph, and when I'm looking, it makes it a little bit easier. Okay, so there they are. They want us to write the equation in this form. So notice that it says sine, so I want to start with the sine values, and I want to write the equation. I'm going to pull the information from the graph that is the easiest. So a D I know comes from the midline here, and so I can see that that is at 11. The next part is the amplitude, the A value. That's the next easiest to pull. That's from the center to the top and the center to the bottom. And so we can see that is 5 units. From 6 to 11, there's 5, and from 11 to 16, there's 5. So I know my amplitude is 5. All right, the next thing I'm going to do is get the period. And you can do that from any points, but in these particular graphs, the easiest ones are right here. That's one full cycle of my curve. And so it went from 2 to 14. So my period is equal to 12 in this case. So I've almost got everything I need here. Now that I've got the period, I know that 2 pi over my b value gives me the period. This is one that I told you, sometimes you can see it easily, sometimes you can't. This one is not as easy to see, but I can cross multiply and just solve like I had before if you can't see it. And so that is 12b equals 2 pi. And then I divide by 12. And so my b value is pi over 6. All right, so we've got D, we've got A, and we've got B now. So the last one that we need is our C value to see if we moved right or left. And we can do that by looking at our graph again. So this was 511 here. This is 216. I'm going to go ahead and work my graph backwards. And so this would be -1 and 11. All right, since we know this sine graph starts right on that midline and looks exactly like this would be one cycle of it, but it starts right at the origin at 0, 0. Now we know this has moved up 11 from the D value, so that gives me this part, but I'm not at 0 here. I've moved to the left 1 unit. So now I know that my C value is -1. And so now it's time to write this equation. All right, so I have written my equation here. Just to summarize, for the equation, I need an h of t equals, or else it's not an equation. Then I have my amplitude of 5, which is a vertical dilation. I've got my horizontal dilation. And then I've got my horizontal translation, left 1. And then my vertical translation of up 11. So we've written the equation. That is one of the parts of the FRQ3. So you are going to have to be able to write the equation once you have the point values of that. Make sure you understand how to get each part of it. All right, thanks for following. Next time we'll go further into our transformations with sine and cosine.